Find the solution to f of x given that f of x is the integral of 1 over square root of quantity 1 minus x squared. Okay, so this is the dreaded trig substitution. So this is probably the hardest type of integral problem you'll see on the AP exam. You'll probably see harder integrals, but this will be as a general class of problems, this will probably be one that's more challenging. So the mnemonic that I use, or the way my spider sense is tuned, is you look for two perfect squares, or two squares, perfect squares, two squares in the denominator under a square root sign. So you see a square root sign, 1 is a square, 9x squared is a square, 3x. And so that's the cue that you're going to use inverse trig substitution. And then your question is, all right, so what are we going to substitute here? Well, the mnemonic I use is if the negative is with the x, if the negative sign is with the x, then you're going to use sign. If the sign is with the constant, so if it was 9x squared minus 1 square rooted, then you'd use secant. And if you don't have a negative sign at all, if it was a plus sign, 1 plus 9x squared square rooted, then you'd use tangent. But this one we're going to use sine, because the sign is with the x squared. So you'd say that x equals 1/3 sine of u. And the idea is the reason you have this 1/3 is you want to get this 9 down to 1. You want to have a 1 for both terms here. So you're going to use 1/3. And you're like, oh, it's so much information. Am I going to forget? You might forget. But one of the nice things is, if you remember most of it, then you can kind of guess and check. So if you forgot the 1/3, then you'd be like, oh, you work through it, and you feel like, okay, something went wrong here, and be like, I missed something, and you can go back and find it. These are difficult to do correctly the first time, but if you have enough time, you can kind of work through these, and they kind of make sense. So, but in the end, you're going to have to do a reasonable amount of practice. You should know inverse trig substitutions. You should have a general idea of how to do them, but it's not worth becoming like 100% proficient at them, because it won't be that heavily tested on the AP exam, and so you don't have to go all out with super levels of expertise here. Okay, so take the derivative of both sides. 1/3 derivative of cosine is, or derivative of sine is cosine. And so when we write this f of x, which I guess has now become f of u, that sounds vulgar. Didn't mean it as such. Okay. Integral 1 over 1 minus 9. And we know what x is, so I'm going to write up here what x squared equals, which is 1/9 sine squared of u. Some people can do that in their head. I probably could, but I don't like to risk it. Sine squared of u square rooted times dx, and dx is 1/3. There should be a du here. The reason that du there is the chain rule. So you take the derivative of the interior, and the interior is u, so derivative of u with respect to x. 1/3 cosine of u du. Okay, rewrite this again. Now after you do this about 1 billion times, which you may or may not want to do depending on how good you want to get at it, you can basically start skipping steps, because you'll be like, okay, I can see where this is going. I try not to skip steps though if I can help it, because I am not that proficient. Especially not proficient at doing cosine of u. Okay, 1 minus sine squared of u square rooted. And so we know that sine squared plus cosine squared, I know there should be like a little x in there. I'm not going to write it just because I'm lazy. Cosine squared equals 1 minus sine squared. Therefore, cosine equals square root of 1 minus sine squared. So I took the Pythagorean theorem, rearranged it, square rooted both sides, And now I can see that this is in fact equal to 1/3 integral cosine of u over cosine of u du, which equals 1/3 integral of 1, because those cancel out each other, become 1 du, which gives us 1/3 u. And then there'll be a plus c involved, but I will leave that off for now. Okay, I'll put it on. And we know that u, we'll have to solve for u now. So, looking at this equation, we have sine of u equals 3x. I change colors to show that I change thought processes. U equals arcsine of 3x. Some people write arcsine like this, but that gets me confused with if it's 1 over sine or arcsine. So I like to write arcsine just to be a little bit more explicit, minimize the confusion. So we have 1/3 arcsine of 3x, arcsine 3x plus c. This is actually probably a different c than that one, but it's okay. I'm fine with it. I'll just write it, call this C1. Maybe, yes. 1/3 arcsine 3x. Is that true? That seems true. Alright, that might actually be their whole thing here. I'm going to copy this, move it over. Okay, I'm just going to move it over. No copying. See if this is a possible answer. F of x, that's, get out my color of triumph. I guess in this term it's going to be dark purple. 1/3 arcsine 3x. And they say a solution, so c equals 0 would be a solution. And it'll be 1/3 arcsine of 3x. Yep, and that's the answer. Dun, dun, dun. Arcsine, yep, not arcsecant. Yes. So that's the answer, and that's how this is a relatively straightforward trig substitution, but it's good to do. That's how you solve this kind of problem. And I will see you on the next one.